Okay, now on to expanding double brackets with surds. Okay, so kind of just following on from the previous video where we looked at expanding single brackets, now onto double brackets. And again, you've probably seen this before at GCSE, so it's just applying what you know, but involving surds. Okay, so when you expand double brackets, you want to multiply out using your claw method. That's the way that I go through it, which is your first term by your first term second bracket, first by second by first, and second by second. And you're timesing those terms together. Okay, so the first one, this is actually the difference of two squares, this one, but I'll ignore that for the time being. Okay, I'll talk through at the end, but let's just go through it like this. So the first bit, we're doing 5 times by 5. Okay, let's write it up here. So we've got 5 times by 5, which is 25. You've then got 5 times by negative root 2. So 5 by negative root 2, which we're just simply going to write times by negative root 2, which is going to be negative 5 root 2. You're then doing a plus 2 root 2 times by a 5, which is going to give you plus, so we've got a root 2 times by a 5, which will give you 5 root 2, so plus 5 root 2, okay, and then you've got a root 2 times by a negative root 2, okay, root 2 times by a negative root 2. Just be careful, right, that negative does not belong inside the surd, okay, you're just doing, well, effectively 1 times by that negative 1, which is negative 1 or just negative, and then root 2 times by root 2, we know from our laws of surds, will just be written as root 4. Okay, because this is actually the difference, sorry, this is the difference of two squares, right, these bits are going to cancel. Negative 5 root 2, add 5 root 2 is 0. So we're left over with just 25, and we've got root 4. Root 4 is equal to 2, so it's going to be negative 2. So take away 2. 25 take away 2, which is equal to 23, and that is your answer. Okay, you could be a bit crafty, and you might have noticed that this is actually the difference of two squares. Okay, what I mean by that is you've got, let's write it in blue. In the first bracket, you've got a plus b, and your second bracket, you've got a take away b. So it's going to go to a squared take away b squared, right, where a is equal to 5, so it's going to be, in our case, it's going to be, a is 5, so it's going to be 5 squared, which is 25. Take away b is root 2. Root 2 squared is just going to be equal to 2. So 25 take away 2 is 23, which is exactly what we got up here. So we can actually go and apply that up here as well, because again, this is in your difference of two squares form, a plus b and a take away b. You could go and expand it by using your claw method, but you know, if you can, you want to save yourself some time, because that's always a good thing to do in maths, right? We've got the difference of two squares, we've got a plus b, a take away b is going to go in the form a squared take away b squared. This is the difference of two squares, okay? Where a is equal to root 3 this time, and b is equal to 7. Therefore, okay, well, a squared, well, what's root 3 squared? Okay, well, root 3 all squared. Take away b squared, b is 7, to take away 7 squared. Root 3 squared, okay, the root and the square cancel, you just get 3. Take away 7 squared is 49. 3 take away 49 is equal to negative 46, okay, and that is your answer for this one, okay? Good, good, good. You could, if you wanted to, have gone through each term, root 3 by root 3, root 3 by negative 7, so on and so forth, but if you can, let's try and save some time. Okay, example 7, a little bit trickier just because we've got sort of more things going on here, but let's go through it. This one isn't the difference of two squares, so we've got to expand it just normally. So we've got to go and do your first term by your first term, first by second, second by first, and second by second. So we've got 2 root 2, root 3 times by 2 root 6. Well, the 2 times by 2 is going to give you the 4. You've then got root 3, sorry, you've got root 3 times by a root 6. Using your surd law, that's going to be root 18. So 4 root 18. First bit, you've then got 2 root 3 times by negative 5 root 3, or 2 by negative 5 is going to be negative 10. Root 3 times by root 3 is equal to root 9, so 10 root 9. You've then got 3 root 5 times by 2 root 6. 3 times by 2 is plus 6. You've got a root 5 times by a root 6, which is going to be root 30, so root 30. You've then got a 3 root 5 times by a negative 5 root 5, or 3 times by negative 5 is negative 15. You've then got a root 5 times by a root 3, which is root 15. Now, if you can, you've got to simplify the surd parts if you can break them down, which with root 18 we can do. So we've got 4 times by the root. Root 18 you can write as 9 times by 2, which is good because 9 is, we can break it down because it's a square number. Root 9 here is simply equal to 3, so it's going to be negative 10 times by 3, so it's going to be take away 10 times by 3, plus root 30, you can't simplify it down any further, so that's going to be keeping it as that. Sorry, let's move this out of the way. So it's going to be plus 6 root 30, because remember root 30, right, there's not two numbers that times together to make 30, where one of them is a square number, so you leave it. And the same with 15, right, you can't break down 15 any further because there's not a square number that times to make 15. So it's going to be just take away 15 root 15. Okay, good. So then we've got, right, over here, we've got 4. Root 9 times by 2, well, root 9 is just equal to 3. So 4 times by 3, then we've got that root 2 still there, which we just go and write as root 2. This just means we're doing 4 times by 3 times by root 2. We've then got negative 10 times by 3, which is minus 30. So take away 30. We've then got plus 6 root 30. Take away 15 root 15. So 4 times by 3 is 12. 12 root 2. Take away 30. Add 6 root 30. Take away 15 root 15. And actually, even though it looks really messy, right, that is your answer, because we can't go and add any of the terms together because, well, root 2 is not root 30 or root 15. They're not like terms. You can't combine them. And you can't break down root 2, root 30, or root 15 any further. So that is simply your answer. Okay? So you can now go and try the your turn, and let's go through this one now. Okay, so expanding this, again, first term by the first term, first by second, second by first, and second by second. So 3 root 15 times by root 10 is going to be 3 lots of root 50. Okay, and then you've got 3 root 5 times by 2 root 5 is going to be 3 times 2 is plus 6. Root 5 times by root 5 is going to be root 25. We've then got negative 4 root 7 times by root 10 is going to be negative 4 root 70. You've then got a root 7 times by a root 5, which is going to be plus root 35. And if you can, you've got to break these down a little bit further. Root 50, you can break down further because it is equal to 3 root 25 times by 2, because 25 is a square number. 25, root 25 is simply equal to 5, so it's going to be plus 6 times by 5. You've then got take away root 70. You can't break down any further, I don't believe. We can check it on a calculator. You type in root 70, it comes out as root 70, so you can't break it down any further. So take away 4 root 70, and root 35, you can't break down any further. So just keep it as plus root 35. Okay. Then this bit, right, root 25 is equal to 5, so it's going to be 3 times by 5. You've got the root 2, which is still there. You've then got 6 times by 5, which is plus 30. You've then got negative 4 root 70 plus root 35. Okay, so then just clearing up a little bit more, you've got 3 times by 5 is 15, root 2, add 30, take away 4 root 70, add root 35. And this, even though it looks really ugly, okay, it is your answer. One, because root 2, a number, root 70 and root 35, they're not like terms, you can't combine them. But also, right, root 2, you can't simplify any further because it's prime. Root 70, you can't break it down because there's no numbers that times together to make 70, where one of them is a square number, and the same thing with root 35. So it looks messy. It is the way it is, but that is definitely your answer. And that is it for expanding brackets with surds. Thank you.